We are starting this series of Mastering Multi-Cloud Complexity webinars in order to allow you and a lot of customers to understand VMware strategy, VMware solution for the area that's growing and evolving. I will show it. The agenda will be why we are going to show a unified management solution, why we are calling it complexity. And today we are going to focus on the automation part of this, on the unified solution. We will have an additional webinars in this series that we talk about cost, operation, etc. We will discuss about it during the session. Together with me, we have Adiel and Diev from TeraSky. They are leading the cloud delivery and cloud automation in TeraSky. And they will deliver the demo and will show you actual usage of the system. I strongly encourage you to ask questions in the Q&A, and let's start again. So in VMware, we did a few researches and following, let's say, the benchmarks that we know, we see a lot of app transformation, modernization of apps. New apps are developed in a cloud native way directly to the public clouds. And most of the CIOs of the companies are expecting to be multi-cloud by 2024. Meaning of multi-cloud, that's mean they're going to be more than one public cloud. For those of you that's asking about the on-prem environment, we can consider it as an additional cloud environment. So managing multiple public clouds brings some complexity. We have distributed applications, we have distributed workforces, and we see customers from around the globe in different regions, different time zones, and a lot of tools that you need to use in order to manage and use your public clouds environment. When we get to such deployment of a new app, so we are following and finding ourselves with a few challenging questions. Which apps should we deploy? To which cloud? Are we applying policies for the different public clouds, each one with its own recommended policies? Are we following the policies that the organization set for us to the public cloud and for our applications? What are we doing with the cost versus performance? It's always a trade-off between those two. And if we are optimizing the cost correctly, not on one cloud account, but in multiple ones. And the last question is, do we have global view that's centralized the cost, security, and performance across those platforms? So in VMware, our strategy and solutions aligned in the following aspects. We are dividing the to various pillars. The first one is managing the cost. Okay, it's to show chargeback, rate optimization, where we can do to minimize the cost spent of the organization. The second pillar is operation. Are we doing good observability for our application or for the full stack? What are we doing with the log management and the application monitoring? And the last one is automation. Are we applying guardrails correctly? How do we leverage our infrastructure as code on different public clouds and on premises? Are we applying secure cloud configuration in an automated way? And for that, we can, with our new brand of products, VMware Aria. VMware Aria, it's the multi-cloud management story from our side, from VMware, and that brings us to a few pillars and solutions that's integrated together to one amazing tool, let's say, VMware Aria Hub. So VMware Aria Hub is our multi-cloud management solution. It's powered by GraphQL. Those of you that's familiar, It's a very interesting project about complex database that's known to maintain and learn a lot of connection between objects. On top of it, we are extending the Aria Hub with our different products for various solutions to the different pillars. We have Aria Cost. Some of you probably know it as Cloud Elf before. Aria Operation, that's provide the full stack visibility, end-to-end troubleshooting, log management, etc. And Aria Automation, that will automate and configure our application and infrastructure deployment, and will allow you to enforce your policies, guardrails, etc. On your public cloud and on-premises area. So today we are going to focus on the automation part, as I said, and in the next webinars, we will discuss additional areas. So what is Aria Automation? Aria Automation designed to be a self-service for multi-cloud. It's a self-service portal that will allow you to provide multi-cloud automations with governance. That means providing the developers, DevOps, IT, and various users in the organization the option to consume cloud services, consume and manage cloud services with governance and making sure that they are doing it correctly according to the best practices of the organization. So we have various use cases that we get with Aria Automation. The first one, as I mentioned, is the self-service for multi-cloud. We support various public clouds and on-premises environment. The entire tool build DevOps oriented. That means we will discuss it deeply, but it will allow your infrastructure to become DevOps oriented, to get all those barriers out and be more aligned to the DevOps methodology. We can provide Kubernetes automation to deploy Kubernetes clusters, namespaces, etc., and provide different services in the Kubernetes area, and security operations and network automation. That means to allow you do governance at security area and in provisioning network, and not just simple services as VM, EC2, etc. Aria Automation is the product. It built from a few services. I will go over them briefly, but I will not go deep dive because the NDF would show this in the demo. So we have the Aria Automation Assembler. It's the tool where you build your services and orchestrate your infrastructure provisioning and management. We got Service Broker or Consumption. This is the customer-facing portal where you can configure your services and aggregate multiple services from multiple areas. Pipelines. It's a service that will allow you to create pipelines, same as Jenkins or any other pipeline tool, with a lot of complex and integration to options. Orchestrator, it's a tool that will allow you to create workflows from basic to complex one, with a lot of integrations to various components, and built in with tons of pre-built, pre-created workflows that you can customize and change. And we have Aria Config, previously named SaltStack. It's a software configuration management capability, will allow you to do configuration management based on events and validate that your environment is configured according to your state files. When we are talking about Service Broker, so what is actually and how it looks like? So we have a self-service portal that will allow you to share services to your DevOps, SREs, IT, and actually everyone in the organization that we want to consume services. We can consume services from Aria Automation templates. We can have Terraform templates. We can, for example, share AWS CloudFormation templates that's created in your AWS account, OVA images, orchestrator workflows. That means you can expose, we call it X as a service. That means you can develop whatever automation you want and allow consumers to use those automations in your self-service portal in managed way. Also, we can show pipelines and allow executing of pipelines directly from the portal. And all of this magic, or all of this service catalog, is applied and managed with policies behind the scenes. That means that if we are allowing user to have request forms, for example, you can see here, we have dynamic request forms with various inputs. We can change the inputs and make them to be very, very dynamic and customizable. We can bind between them and allow different things to different users. I will talk a little bit about about how we see from the Aria automation the various components. So we are having governance on top of all the self-service portal. That means you can allow to share different services to different users. You can set list policies. That means I will allow this service to be enabled or deployed for 30 days, 1 day, etc. We can set the tagging policies, naming convention. We can set complex approval workflows and entitlements to different users. Also, we are setting the resource policies or the quota for per user or project that will allow them to consume just the resources that you want to allow them to use. The tool can work with the different cloud zones, different regions. We currently support the top 3 public clouds. So that's from the architecture and the different objects. As the entire tool build, as I said, DevOps oriented. That means everything you configure will be configured with infrastructure as code. All the services are infrastructure as code. All the components are integrated to Git. That means you can manage it directly in Git or in the product. And we also allow a robust service of pipelining that will allow you to create various pipelines that integrate with your Jenkins, Git, etc., to create some flow or continuous delivery pipelines for your environment. The Aria automation assembler, or how we build the templates, as you can see, it's infrastructure as code tool. It's side-by-side with the YAML file and graphic interface. That means you can do one change in the graphic interface and it will be populated as infrastructure as code, and the other way. Okay, we can expose in our YAML file various properties. We have native objects. We can use the item project as one of our infrastructure as code languages. We can use Terraform, and we can also integrate Ansible or SaltStack for configuration management. For example, if we will leverage the Terraform integration, we can use any Terraform provider to provision custom objects. That means, although we are supporting various objects, you can deploy any Terraform file that's you already created. You don't need to change it. You just need to expose it in the service catalog. It can also be part of a complex blueprint that will provision your entire service. That means, for example, here we are deploying a network with a few front-end servers, backends, and an additional Terraform resource. I mentioned it for Aria config about integrating the configuration management. So in the same YAML file, we can, those of you that are familiar with Salt or not, it's an open source project that will allow you to create state files or configuration files for your environment. In this example, you can see that we are deploying one VM and applying different state files. We are applying Apache, for example, and that will make sure that this VM will be deployed and Apache installed and configured. So I will skip about the state files because we are quite on time. We have some special object in vRealize automation or Aria automation called Cloud Machine. Cloud Machine, it's a cloud agnostic provisioning. That means you can configure the template once with your cloud machine, and according to various tags or inputs in the service portal, it will provision the machine to different clouds with a different object. For example, what we see here, that's if we select production is the environment, that will provision VM in vSphere. But if we will set dev, it will go to AWS, and if it's test, can be Azure. And of course, that's customizable, and you can check and select whatever you want. I mentioned that we have approval policy. So for every service, it's never mind if it's deploying EC2, if it's creating new VPC or any other service that you will allow your users to consume, we can have approval process, multi-level with the multi-approvers. And it will allow you, for example, if the deployment cost is too high, to get an approval from someone that's need to make sure this is allowed to provision. Also, we can use list policies. That means that every object that we are provisioning can be deleted sometime. If, for example, for our CI/CD to show that our deployment will stay only for 1 day. Aria automation pipelines, as I said before, will allow you to create different pipelines with a lot of integrations, a lot of endpoints. Adiel will show it in a few minutes. Very robust tool. And also we can take every pipeline and expose it in the service catalog to users with the various inputs. In Kubernetes automation, we can have provisioning of Kubernetes clusters. We can deploy Kubernetes namespaces. We can allow user to consume Kubernetes zones that they can create their own Kubernetes clusters and use them for their own usage. And that's it for now. I will allow Adiel and Diev to go over the demos. I think it's more interesting than slides, and I will be happy to answer any questions in the Q&A.
Hi, thank you, Liron, for the introduction. Now let's go see the demo environment. 1 second, sorry. Can you see my screen, Liron?
Yep.
Yeah, perfect. So it's a pre-recorded demo. As Liron mentioned, VRA is a highly customizable tool that can answer many needs, some of them beyond the classic infrastructure boundaries or classic DevOps boundaries. We'll go about a few of the options we have here. We'll discuss. We'll start with the service broker. This is the UI. We press the service broker user, which is designated for the end users. And here we can see the catalog items. We can filter them by different categories. Here we can see some Ansible Dockers, treater application on premise, treater application on AWS, Terraform, TAP, and few access variations. our users can be a part of multiple groups. And when they consume a catalog item, they can choose from which group, from which project this catalog item will be consumed. It will affect the quotas, the limits, the policies, different visibilities. Different groups can see different items. We can see on the left, we have content types. We can use AWS, CloudFormation templates, VMware, Marketplace, CodeStream, VRO, and many more. So it gets easy to navigate for large organizations which has multiple multiple automations and services. Here, for an example, we have some custom automations we decided to showcase. In this request, we can get data from airports to see if our colleagues, what happened to their flight. In this example, let's choose the Amsterdam airport. Let's see El Al Airlines in this airport. And here we can see live the flights from the portal. You don't have to submit anything. It's a live form that get the data live, not final, final departed. Basically, we can automate anything if it has an API or a CLI. We can do it. Just one of our examples we can implement here. And now let's dive into cloud agnostic, the multi-cloud challenge as we started to discuss it. The VRA could be a unified platform to consume all those services from different public clouds. We have for this example, the cloud agnostic blueprint, which is general input form. We choose the deployment name. You can consume it through UI. You can consume it through API with different tools. And we can, in this example, we'll choose the target environment, AWS. We can change, for an example, number of front-end workloads to 3, the threads, and we hear the deployment's running. Inside the request, we can see the history. We'll start with some allocation to see we have 3 resources, we have network, compute, storage. Once it's done, you can always go to the history to see if you have some bottlenecks in the deployment. In this case, it took us 2.5 minutes. As you can see, it created on 347 and completed in 350. And here we have the whole topology. We have the network, the load balancer, the front end, the backend, and the database. You can select each component. And on the right, we can see the properties, the IPs, the region, the tags that you have, 3 front ends as we requested, the region, all the initial high-level information your user might need is here. It's easily to consume, easily to show. Again, you can show it through API as well. Consume it through API as well. We have here we have the general information. Now let's try to request the exactly same blueprint, but this time let's go to the on-prem environment without changing anything. It's the same catalog item from the user or the API. It's exactly the same. We just will modify the target environment. Instead of AWS, we'll choose the on-prem vCenter. This time we'll choose one front end, and we'll see how it goes. As you see, it's the same catalog item, cloud agnostic. 01 is on AWS. It could be, if you would like, fully transparent to the user. You don't have to choose AWS or on-prem. It could be dev, staging, prod environment, testing, silver, bronze, or whatever is fitting the organization. While the resources are being created, the topology is automatically loading those resources. And now we can see in this example, the topology is very similar, front-end, back-end database, but now it's a vCenter VM, VMware vSphere VM, together with NSX that provided us the networking. It's a vSphere machine. This time it took 2 minutes to deploy the whole VM in our environment. Here we can see all the steps were requested. If you have approvals, as Liron mentioned, you will see them in the history as well. For each resource, we can provide, automate, customized second-day operation. What it basically means is we can give our users or additional data operations that not existing out of the box. We can create anything here, create additional automation and publish. We can limit the, for an example, where you don't want your end user to delete, only to power off and then to archive. We can implement it as well. We had actions on the deployment, and we have per resource: resize, change boot disk, power off, take backup, take snapshot, depends on the resource, change tags. And we have this feature out of the box called update. For an example, for my existing application, I want to change the amount of frontends to 2. I don't need that many manually. And it will show what will change. It will update the following applications. It will delete one frontend. In this case, the last one. Let's submit this request. And in a few seconds, we will see that the load balancer was updated. The frontend, the amount of frontend machines became 2 instead of 3. And magic of the pre-recorded demo, the operations completed. We see again in the history, and now we have only 2 frontends with all their details, and the load balancer, of course, was updated as well. Here we can see all the information, and only 2 instances with their IPs and which region, because it's AWS. You can increase, you can modify, you can update, depends on your blueprint. Let's deep into the blueprint. For this, we'll go to Cloud Assembly, which is the service designated to create and modify the blueprints. And let's dig into Cloud Agnostic and see how it looks behind the scenes. Here on the right side, we can see the code, and on the left, the canvas. They fully in sync. If you modify or add additional component of the canvas, it will showcase on the code, and the other way around. When you select a component on the canvas, it's already highlighting the part of the code. Here we have some properties: name, image, tags, networks, and everything related to each agent. If it will be in AWS, then we will install a CloudWatch agent. And at the bottom, we can see a cloud config. During the deployment, we execute a cloud config for our application. The packages, the username, custom scripts, basically everything we need for this application. We can put here all the CMDs, the commands, the exports, and this is for the frontend. Each frontend will execute it. We have the same for MySQL. Again, different cloud front. We can customize it to whatever we want. We can put here custom resources. If you have a third-party application you're using in your organization, which is not part of a VRA out-of-the-box compatibility list, you can develop and create your own resources that will be managed by VRA, including data operations. It could be a CMDB record, it could be IPAM integration, or anything you could think of. For some convenience, we can go to properties. And here is more UI-based editing tool. We have everything we have in the code, we have here in the UI, and the inputs for the whole deployment. If you would prefer to create the inputs in this form and not the code, you have it as well. Here are the inputs as code, as UI. We always have the ability to test our blueprint. When we're creating a new blueprint, we don't want every time to deploy, delete. We have the option to test. Here in this example, we'll choose, for an example, AWS with 3 frontends, and let's see. And what it does, it kind of plans to see it has the availability resources, all the constraints are matched, you have the required profiles, syntax, everything is there. So you can publish the catalog item to your end users. Until you, as long as you didn't publish the catalog item, your end users will not see it. This is the high level. We could, in this example, we had AWS and on-prem. It could be almost anything. And from the end user perspective, DevOps perspective, they have a unified API that will kind of mask the whole infrastructure if the organization don't want to publish the IT or limit some access. VRA could be the tool for this unified management, including approval policies, custom validations, quotas for groups. We have an expiring option. For an example, even if AWS, you don't want VMs to live more than 30 days, you can configure a policy that will automatically, after some archiving period, will delete them. Now I will give Adiel a word. He will showcase a more interesting, a more complicated use case. We created more DevOps oriented, how to create pipelines, how to integrate different solutions, and hopefully you will find it interesting as well. Thank you for your attention. Adiel.
Hi, thank you, Yev. It was a very interesting demo. Now I will show you what you could do with what we've just seen. Let me share my screen. So we will go over. Can you see my screen, guys?
Yes.
Great. So now we'll go over several things that Liron mentioned and some extras that we went through the basics of how to provision cloud agnostic entities on the VRA. And now what we can do with this. So at first we'll see here how to provision a Docker host through our service broker. So we simply go to the service broker. As we said, we have several catalog item types, and now we will use a VMware cloud template catalog item, which will provision a Docker host using Ansible. So we'll input the deployment name and the VM name as an input. It has an input for the form, which is Docker 01. We click submit, and we'll see our request again. Navigating into our request will show us all of the information we chose from a cloud template, Ansible Docker app cloud template, and we'll also see the history. We'll just skip the video. It will provision, create successful. So now we can see here on the request our events, the topology itself as well on the left pane. But we can see it on the events that it created a virtual machine, the network object, and had an Ansible playbook running, which we'll see in a moment what it did. Okay, so we'll also see it on the topology. We have the IP address of the virtual machine. And all of the properties, the playbook properties, what it ran, on which inventory file we put this host at. And we will navigate to our host. So this is our provisioned Docker host. So we can see here we have a new virtual server. It is provisioned on our vSphere on-prem environment, and there is a Docker installed here. Okay, from an Ansible playbook. Okay, so now let's go over our blueprint, what it really does. Okay, so this is how our blueprint look like. We saw that we're provisioning from Ansible Docker app. Here we have virtual machine with a playbook attached to it. We can simply drag and drop our playbook from the left pane, okay, and then edit it here. Place the inventory file that we would like to place our host at. Our password, and the playbook that we would like to provision. We have many properties that we can select. The bottom line is after the virtual machine is provisioned, we integrate with the Ansible server that is previously integrated with the VRA and execute the pipeline, the playbook. So as we can see here, this is our Ansible server. And we have our playbook, which installs a Docker server. So this is like a post-provisioning flow to install the Docker. Okay, so switching into pipelines, I have a different video on that. A code stream pipeline actually takes this blueprint and fits into a bigger pipeline. A pipeline can also be consumed from the service broker. As we saw, we have a different catalog item types. Now we will select a code stream pipeline, which we can execute it from here as well. Now we see all of the pipelines. We have a catch them all pipeline, which will take this blueprint and install this our Docker virtual machine and run on top of it our application. I will explain it all soon. We'll just see what we can create a pipeline from here, and all of the pipeline will execute. We'll go over the exact things the pipeline does in a moment. So we can see here all of the history of our pipeline, and it has an approval. It means that I cannot run the pipeline myself. There is a hierarchy that needs to approve this pipeline execution. I'm also my user also can approve this. So we'll go to our inbox here at the right, and we will have as a approver, we will have a new approval request. We'll simply click on this. We can see what was requested. We have only one level here of approvers, and I can simply click approve. And the reason I can also reject, but for the purpose of the demo, I will approve it. After I approve it, the VRA, the Aria automation continues on. We can see it on the history tab. Continues on to execute the pipeline itself or any other object we consume here. Sorry about that. So we can see the pipeline is finished, and we can see the execution from here, and all of the outputs of the pipeline. What are the outputs? We can see that it has successfully ran. It means that we have a virtual machine with our application running, where it got from the application from. Okay, so here we can see the playbook execution. The playbook execution actually has several steps. The first step is to get the image, as we saw here on the left. It builds the image from our Git. We'll see the Git in a second. Push the image to Harbor, and then deploy the virtual machine and install the image on our virtual machine on our Docker host, and test the application. So as we see here, the application was tested successfully. That's why the pipeline is completed successfully. Okay, so let's talk about CodeStream for to see what are how CodeStream is built, how the CodeStream is built, and how is the pipeline, what the pipeline does. Actually, CodeStream has various integrations. We can see here all of our pipelines already pre-configured. If we go to our endpoints here, we can see all of our integrations on the CodeStream. So we have email server integration. So when the pipeline finishes or successfully or fails, it can send an email. We have Jenkins integration, which we can integrate Jenkins pipeline into our pipeline. So when we build the image actually here on our pipeline, you'll see that we integrate it through Jenkins that builds the image and push to Harbor. There is additional SMTP here. A VRO orchestrator. Basically, the VRO can run any workflow that you would like. Our previous catalog item for El Al flights is based on a VRO workflow. We can have any custom code that we would like to run. and we can run from the user's portal as a request or from the pipeline as a part of our flow. We also integrated with a Git server. It's our Git, which the code is actually there, and it also sends webhooks to execute our pipeline. And as well, we have a demo. We have a Docker server additionally to our provision Docker. We also have on the code stream itself secrets. So during the pipeline, we will not have the secrets as a plain text. So the VRA and the code stream can save secrets here. So we can just simply integrate them into our pipeline, for example, to integrate with our Jenkins and supply a password. Okay, so I have triggers, which means instead of going to through the service broker and the end user will run the pipeline, a trigger can be made. For example, a webhook. On this example, we have a webhook on our Git environment. Whenever an update or commit to our repo is made, it will send a webhook to our code stream to execute our pipeline and check the code that is in the Git. So configuring the Git is pretty simple. Webhook is pretty simple. We just have the configuration is very simple, and we just have the secret that we need to implement and the URL that the Git server needs to integrate with. So let's go over our Git briefly, and we will see our code. Our code has actually, okay, our code is our main Python here, which is actually runs an API calls to a Pokemon index. So we can see here, once our server is running, our test case will pull a Pokemon from the Poke API. So we can see it here on the code. Now, to configure here, we just created on our Git webhook. Under settings, on the webhook, it's very simple. We can see here our pre-configured webhook and its URL to the Git integration on the code stream and the secret that it gave us, and our last runs. Okay. So now let's go back to our code stream pipeline and see what it does. Okay. Our pipeline is configured to build, as we spoke. Just 1 second, our video is. Okay, so to go to the pipeline, as we saw, we have the pipelines menu. We simply selected our pipeline, and our pipeline is here divided into several sections: the build image, deploy infrastructure, and then test application, as we saw from our execution. So the first step is to build the Docker image. It's a Jenkins, actually Jenkins that we're running using their integration, our previous integration. And the job there is to build our test image. To build the test image from our code in the Git. Now, our pipeline here will also, it has also various outputs that we can use on our next tasks. So we test here our job, whether it runs successfully or failed. So we can trigger another things or to break the pipeline if the Jenkins job has failed. After the Jenkins job is finished successfully, we will push the image that we created from the code to our Harbor server. It is also a Jenkins job. And it also has outputs, as we can see. And the next step is to clean up our Docker image because it's already on our Harbor server. Okay. The next step on the pipeline is to build the virtual machine. To build the virtual machine, it just simply goes and integrates with the VRA automation itself, create a deployment. As you remember, we have various inputs there, the deployment name, which name of the deployment we would like to have. It could also have variables here, so we will not have conflicts. So we'll take in the build ID there. The template, cloud template name, which cloud template to execute, and the input, what will be the virtual machine name. This as well as outputs. After the virtual machine is ready, our next step is to install the application. So we are SSHing, we can see here. We can see here that we are SSHing to our machine and logging into the Harbor using the variables that we just previously spoke about. We're pulling the image from the Harbor and we're running the image on the virtual machine. After all of this is made, we will test our application that is running. As you saw, we have a unique port for to integrate with our web server that is running there, and it redirects to our Pokemon index API that we saw in the code, and we pull the Pikachu Pokemon. Once that it has also as an output, if it succeeds, we will see as it is a success, and we will send a notification of successful or failure. And we can edit from here the integration of the email. We can when the email complete, when the flow completes, we send the email to the user. Your build is running successfully or failed, and if it was failed, we will need to address this as an issue. Somebody break the code, for example. So let's see what happens when somebody breaks the code. Okay, so we'll go to our Git repo, and let's do something that is invalid. We'll commit a new change here, and we'll change the URL. Once we committed the change, we can see here on our webhooks, it sent a new webhook to our VRA server. You can see it just now. And the new pipeline was executed. On this pipeline, we can see all of the steps again. We'll just move forward here. It builds all of the image, tests the Jenkins job, and deploy the virtual machine after we have the image pushed to Harbor. And we'll test the application. We failed this application on purpose because the URL is invalid. On this stage, everybody gets an email. The application is not running. The build is failed. Here we can see the JSON response from our test, and we can also send it to the email through the email. Okay. So that's basically all about CodeStream and pipelines and approval policies.